Bringing passes into scope with the use keyword. Bringing passes into scope. Bringing passes into scope with the use keyword. So it's about using use keyword. So having to write out the passes to call functions. Having to write out the passes to call functions can feel inconvenient and repetitive. In listing 7-7, whether we chose the absolute or relative passes to the add to waitlist function, every time we wanted to call add to waitlist, we had to specify front of house and hosting too. Fortunately, there's a way to simplify this process. We can create a shortcut to a path with the use keyword once, and then use the shorter name everywhere else in the scope. In listing 7-11, we bring the create front of house hosting module into the scope of the eat at restaurant function, so we only have to specify hosting add to waitlist to call the add to waitlist function in eat at restaurant. In listing 7-11, we bring the create. In listing 7-11, we bring the create front of house hosting module into the scope of the eat at restaurant function. So we only have to specify a thing in the to waitlist to call the add to waitlist function in eat at restaurant. Okay, that makes sense. Hosting, yep. So adding use and path in the scope is similar to creating a symbolic link in the file system. The adding use create front of house hosting in the create root hosting is now a valid name in the scope. Just as though the hosting module had been defined in the create root, passes brought into scope with the use to use. Also check privacy like any other paths. Adding use and path in a scope is similar to creating a symbolic link in the file system. By adding use create front of house hosting in the create root, hosting is now a valid name in the scope, just as though the hosting module had been defined in the create root. By adding use create the hosting in the create root, hosting is now a valid name. Okay, just as though the hosting module has been defined in the create root, just as though the hosting module had been defined in the create root. Passes brought into scope with use also check privacy like any other passage. Okay. Note that use only creates the shortcut for the particular scope in Note that use only creates the shortcut for the particular scope in which the user offers. Listing 7-12 moves the eat at restaurant function into a new child module named customer, which is then a different scope than the use statement. So the function body won't compile. Note that use only creates the shortcut for the particular scope in which the use occurs. Listing 7-12 moves the eat at restaurant function into a new child module named customer, which is then a different scope than the use segment. Listing 7-12 moves the eat at restaurant function into a new child module. Oh, this one. So the customer moves to the eat at restaurant. Oh, okay. Okay. Which is then a different scope. Which is then a different scope. This is then a different scope. This is then a different scope than the user segment. Okay. So the function body won't compile. Oh, makes sense. Okay. The compiler error shows the shortcut no longer applies within the customer module. use declare the create or module hosting. So notice there's also a warning that the use is no longer used in its scope. To fix this problem, move the user within the customer module 2, or reference the shortcut in the parent module with a super hosting within the child customer module. Creating idiomatic user paths. In listing 7-11, you might have wondered why we specify the why we specify the user create front of house hosting and then called hosting add to waitlist in that restaurant rather than specifying the user path all the way out to the add to waitlist function to achieve the same result as in listing 7-13. In listing 7-11, you might have wondered why we specified. In listing 7-11, you might have wondered. In listing 7-11, you might have wondered why we specified. In listing 7-11, you might have wondered why we specified the user create. In listing 7-11, you might have wondered why we specify the user create. Why we specify the user create. Front of house hosting. In listing 7-11, you might have wondered why we specify the user create front of house hosting and then call the hosting add to waitlist in it at restaurant rather than specifying the user path all the way out to the add to waitlist function to achieve the same result as in listing 7-13. In listing 7-11, you might have wondered why we specify the user in the folders rather than specifying the user path all the way out to the there is a function to achieve the same result. Oh, makes sense. So although both listing 7-11, 7-13 accomplish the same task, listing 7-11 is the idiomatic way to bring a function into scope with the use. Bringing the function's parent module into scope with the user means we have to specify the parent module when calling the function. Specifying the parent module when calling the function makes it clear that the function isn't locally defined, still minimizing repetition for the full path. The code in listing 7-13 is unclear as to where add to waitlist is defined. Makes sense. On the other hand, when bringing in structures, enums, and other items with the use, it's idiomatic to specify the full path. On the other hand, bringing in structures, enums, and the other items used, idiomatic to specify the full path, and listing 7-14 shows the idiomatic way to bring the standard version hash map struct into the scope of a binary grid hash map. The full path. There's no strong reason behind this idiom. It's just a convention that has emerged, and folks have gotten used to reading and writing logical this way. Okay. The exception to this idiom is if we are bringing two items with the same name into scope with the use statement. The exception to this idiom is if we are bringing two items. If we are bringing two items, because Rust doesn't allow that. Listing 7-15 shows how to bring two result types into scope that have the same name but different parent modules and how to refer to them. Listing 7-15 shows how to bring two result types into scope that have the same name but different parent modules and how to refer to them. As you can see, the exception to this idiom is if we are bringing two items. Okay, with the same name into scope with the use. with the user segments because the roster doesn't allow that. Listing 7-15 shows how to bring two result types into scope. Oh, FMT result. The exception to this idiom is if we are bringing two items with the same name into scope. Oh, because they are results. Okay, makes sense. As you can see, using the parent modules distinguishes the two result types. If instead we specify the use std_fmt result and use std_io result, we'd have two result types in the same scope, and Rust wouldn't know which one we meant when we use the result, providing new names with the as a keyword. There's another solution to the problem of bringing two types of the same name into the same scope with the use after the path. We can specify as a new local name or alias for the type. Listing 7-16 shows another way to write the code in listing 7-15 by renaming one of the two result types using as. Oh, we can do this, okay. There's another, okay, makes sense. Here's a keyword, okay. There's another solution to the problem being, okay, makes sense. In the second use assignment, we choose the new name IO result for the IO result for the std_io result type, which won't conflict with the result from std_fmt that we've also brought into scope. Listing 7-15 and listing 7-16 are considered idiomatic, so the choice is up to you. Re-exporting names with the pub use. When we bring a name into scope with the use keyword, the name available in the new scope is private. To enable the code that calls our code to refer to the name as if it had been defined in that code's scope. When we bring a name into scope, when we bring a name into scope with the use keyword, the name available in the new scope. When we bring a name into scope with the use keyword, the name available in the new scope is private. Okay. To enable the code that calls our code to refer to that name as if it had been defined in the code scope, we can combine pub and use. This technique is called re-exporting because we are bringing an item into scope, but also making that item available for others to bring into their scope. Listing 7-17 shows the code in listing 7-11 with the use in the root module changed to pub use. So pub use, okay. There's a pub use, okay, makes sense. So before wait a second, creating our source team. But this second involves re-exporting because we are bringing an item into scope, but also making that item available for others to bring into their scope. Oh, create the front of house. Create the front of house hosting. Front of house everything. Before this change, external code. Before this change, external code would have to call the add to waitlist function by using the path restaurant front of house hosting add to waitlist function. Now that this pub user has re-exported the hosting module from the root module, external code can now use the path restaurant hosting add to waitlist instead. Before this change, external code would have to call the add to waitlist function by using the path the restaurant front of house hosting add to waitlist. Okay. Now that this pub use has re-exported the hosting, okay. Hosting has re-exported the hosting module from the root module. External code can now use the path restaurant instead. Restaurant hosting. Okay. Restaurant hosting to waitlist. Re-exporting is useful when the internal structure of your code is different from how programmers calling your code would think about the domain. For example, in the restaurant metaphor, the people running the restaurant think about front of house and back of house. But customers visiting a restaurant probably won't think about the parts of the restaurant in those terms. With the pub use. But customers visiting a restaurant probably won't think about the parts of the restaurant in those terms. With the pub use, we can write our code with the one structure but expose a different structure. Doing so makes our library well organized for programmers working on the library and programmers calling the library. We will look at another example of pub use and how it affects your crates documentation in the exporting a convenient public API with the pub use section of chapter 14. Using external packages. In chapter 2, we programmed a guessing game project that used an external package called rand to get random numbers to use rand in our project. We added this line to cargo.toml. In chapter 2, we programmed a guessing game project. In chapter 2, we programmed a guessing game. In chapter 2, we programmed a guessing game. In chapter 2, we programmed. In chapter 2, we programmed a guessing game project. In chapter 2, we programmed. In chapter 2, we programmed a guessing game project. In chapter 2, we programmed a guessing game project that used an external package called rand to get random numbers to use rand in our project. We added this line to cargo.toml. 083. Adding rand as a dependency in cargo.toml tells Cargo to download the rand package, and any dependencies from crates.io and make rand available to our project. Then to bring rand definitions into the scope of our package, we added a use line starting with the name of the crate. Rand and listed the items we wanted to bring into scope. Recall that in the generating a random number section in chapter 2, we wrote the RNG trait into scope and called the rand thread underscore RNG function. Then to bring the definitions into scope of our package, we added a use line starting with the yes, makes sense. Trade rand and listed and listed the items we wanted to bring into scope. And listed items we wanted to bring into scope. Recall that in the generating an random number section in chapter 2, we brought the RNG trait into scope and called the rand_thread_RNG function. Use a line starting with the name of the clade and then listed the items we wanted to bring into scope. Recall that in the generating number section in chapter 2, we brought the RNG trait into scope and called the these items we need to bring into scope. Okay, recall that. Okay, the trait into scope and call the RNG thread and function. Okay. Members of the Rust community have made many packages available at traits.io, and pulling any of them into your package involves these same steps, listing them in your packages, cargo, the toml file, and using use to bring items from their crates into scope. Note that the standard std library is also a crate that's external to our package. Because the standard library is shipped with the Rust language, we don't need to change cargo.toml to include std, but we do need to refer to it with the use to bring items from there into our package scope. Note that the standard std library is also a crate that's external to our package. Because the standard library is shipped with the Rust language, we don't need to change cargo.toml to include std, but we do need to refer to it with the use to bring items from there into our package scope. For example, with the hash map, we would use this line. This is an absolute pass starting with the std, the name of the standard library crate. Using nested paths to clean up large user lists. If we are using multiple items defined in the same crate or same module, listing each item on its own line can take up a lot of vertical space in our files. For example, these two use statements we had in the guessing game in listing 2-4, bring items from std into scope. Using nested paths to clean up large user lists. Using nested paths to clean up large user lists. Okay, using nested paths. If we are using multiple items defined in the same crate or same module, listing each item on its own line can take up a lot of vertical space in our files. For example, these two use statements we had in the guessing game in listing 2-4 bring items from std into scope. Instead, we can use nested paths to bring the same items into scope in one line. We do this by specifying the common part of path, followed by 2 colons, and then curly brackets around the list of the parts of the paths that differ. As shown in listing 7-18, specifying a nested path to bring multiple items with the same prefix into scope. In bigger programs, bringing many items into scope from the same crate or module using nested paths can reduce the number of separate user statements needed by a lot. We can use a nested path at any level in a path, which is useful when combining 2 user statements that share a subpath. For example, listing 7-19 shows 2 user statements, one that brings the stdio into scope, and one that brings stdio right into scope. The common part of these 2 paths is stdio, and that's the complete first path. To merge these 2 paths into one user statement, we can use self in the nested path, as shown in listing 7-20. Use stdio self right. Listing 7-20, combining the paths, listing 7-19 into one user statement. This line brings stdio and stdio right into scope. The globe operator. If we want to bring all public items defined in a pass into scope, we can specify that pass followed by the star globe operator. If we wanna bring all public items defined in the pass into scope, we can specify the pass followed by the star. Oh, okay. We wanna bring all public items, all public items. Okay, all public items. Use std collections. Sorry, okay. This user statement brings all public items defined in std collections. Into the current scope. Be careful when using the globe operator. Globe can make it harder to tell what names are in scope and where a name used in your program was defined. The globe operator is often and when used when testing to bring everything under test into the testers module. We will talk about that in the how to write tests section in chapter 11. The globe operator is also sometimes used as a part of the prelude pattern. See standard library documentation for more information on the pattern. Which of the following statements best describes the function of the user keyword? User copies the contents of an item from one module to another. User reduces the verbosity of referring to items in the user path. Allows access to items that circumvent normal privacy rules. Use indicates to the compiler that an item will be used and should be optimized. Use allows access to items that circumvent normal privacy rules. Consider this module and user statement. Oh my god, user parent. Okay, parent and then doing this star and then child at alias. Alias. Instead, inside the main, how many passes to A, B, and C are created by user statement? A, okay, I think HA, and then public module, right? So A, one, two, seems two, one, two. Please, oh shit. Usually this is the verbosity of referring to items in the used path. Ah, basic use case verbosity. Referring. Oh yes, we can reduce this. Okay, verbosity. Okay. Okay, that makes sense. Makes sense. Okay, makes sense. And then write 3. So context the star asterisk imports A and child, but not the private B. The edge also renames child to alias. Therefore, the user creates 3 possible paths A, child C, and alias C. Oh shit. One A, and then child. Okay. Separating modules into different files. So far, all the examples in this chapter define the multiple modules in one file. Separating modules into different files. Separating modules. Separating modules. Separating modules. Separating modules. Separating modules. Separating modules into different files. So far all the examples in this chapter define the multiple modules in one file. Examples in this chapter, all the examples in this chapter define the multiple modules in one file. Okay. When modules get large, you might want to move their definitions to a separate file to make the code easier to navigate. So far, all the examples in this chapter define the multiple in one file. When modules get large, you might want to move their definitions to a separate file to make the code easier to navigate. For example, let's start from the code in listing 7-17 that had multiple restaurant modules. We will extract modules into files instead of having all the modules defined in the create root file. In this case, the create root file is src/lib.rs, but this procedure also works with the binary crates whose create root file is src/main.rs. First, we will extract the front of house module to its own file. Remove the code inside the curly brackets for the front of house module, leaving only mode front of house, leaving only the mode front of house. Declaration. So the src lib.rs contains the code shown in listing 7-21. Okay, note that this won't compile until we create the src front of house as a REST file in listing 7-22. Listing 7-21 declaring the front of house module whose body will be src front of house.rs. Next, place the code that was in the curly brackets into a new file named src/front of house.rs. As shown in listing 7-22, the compiler knows to look in this file because it came across the module declaration in the create root with this name, front of house. Next, place the code. Next, place the code that was in the curly brackets. Next, place the code that was in, wait a second. Oh, there's declaration here and then of use front of house. First, we will extract the front of house module to its own file. Remove the code inside the curly brackets for the front of house module, leaving the border front of house. Declaration. So the contains the code shown. So that the src lib.rs contains the code shown in listing. Okay, but this won't compile until we create this front of house LRS file in the listing. Okay, makes sense. Declaring front of house module whose body will be in this. Okay, makes sense. Next, place the code that was in the curly brackets into a new file named as shown in listings. The compiler knows to look in this file because it came across the module declaration in the create root with the name front of house. Using 7-22 definition inside the front of house module in src front of house.rs. Note that you need to load a file. Note that you only need to load a file using a module declaration once in your module tree. Note that you only need to load a file. Note that you only need to load a file. Okay, note that you only need you need to load a file. You only need to load a file using mode declaration. Once in your module tree, once in your regulation, once in your module tree. Once the compiler knows the file is a part of the project, and knows where in the module tree, the code resides is because of where you would put the mode statement. Other files in your project should refer to the loaded files code using a path to where it was declared. That's covered in the passes for referring to an item in the module tree section. In other words, mode is not an included operation that you may have seen in other programming languages. Next, we will extract the hosting module to its own file. The process is a bit different because hosting is a child module of the front of house, not of the root module. We will place the file for hosting in a new directory that will be named for its ancestors in the module tree. In this case, src/front of house. Next, we will extract the hosting module to its own file. Next, we will extract the hosting module to its own file. Next, we will extract the hosting module to its own file. Next, we will extract the hosting. Next, we will extract the hosting module to its own file. The process is a bit different because hosting is a child module of a front of house, not of the root module. We will place the file for hosting in a new directory that will be named for its ancestors in the module tree. In this case, src/the front of house. To start moving hosting, we change src/front of house.rs to contain only the declaration of the hosting module. Okay. Then we create a src/front of house directory and a file hosting rs to contain the definitions made in the hosting module. Then we create a src front of house directory and a file hosting.rs to contain the definitions made in the then we create a src front of house directory and a file hosting.rs to contain the definitions made in the hosting module. To start moving hosting, we change this src front of house.rs to contain only the declaration of the hosting module. File name src/front of house.rs. Then we create a src/front of house directory and a file hosting.rs to contain the definitions made in the hosting module. File name src/front of house hosting.rs. There's a second directory in the file hosting.rs. Oh, did it happen? Okay. If we instead put hosting.rs in the src directory, the compiler would expect the hosting.rs code to be in a hosting module, declared in the create root and not declared as a child. We instead put hosting.rs in the src directory, the compiler would expect the hosting.rs code to be in a hosting module, declared in the create root and not declared as a child of front of house module. The compiler's rules for which files to check for which modules to call means the directories and files more closely match the module tree. Alternate file passes. So far, we covered the most idiomatic file passes the compilers use. But Rust also supports an older style of the file path from module named the front of house declared in the create root. The compiler will look for the module's code in src slash front of house .rs, what we covered. src slash front of house dot slash mode .rs, older style. Still supported path. For a module named hosting that is a submodule of the front of house, the compiler will look for the module's code in src slash front of house hosting mode.rs. Older style still supported path. If you use both styles and for the same module, you will get a compiler error. Using a mix of both styles for different modules in the same project is allowed, but might be confusing for the people navigating your project. The main downside to the style that uses files named mod.rs is that your project can end up with many files named mod.rs, which can get confusing when you have them open in your editor at the same time. We will move each module's code to a separate file and the module tree remains the same. The function calls in either restaurant will work without any modification, even though the definitions live in different files. This technique lets you move modules to new files as they grow in size. Note that the pub user create blah 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 hosting statement is leave also hasn't changed. Nor does use have any impact on what files are compiled as part of the crate. The mod keyword declares modules, and Rust looks in a file with the same name as the module of the code that goes into the module. Imagine a Rust package with the following directory structure: foo-bar, cargo source, level, import. The commands of each file are import and run. Import analysis, import mode, import analysis, run. So import mode analysis. Oh, import. Mm-hmm. Form of the file, okay. Say that another Rust developer is using the foo-bar library created in a separate package, and they wanna call the run, and they wanna call the run function. What is the path they would write? What is the path they would write? And they wanna call the run function. Run. Mm, yeah, separate package, and they want to call the run function. Oh, and it's like a full bar lead, undo, full bar. Mm, full bar info, and then run is analysis. Yes, and then yep, this one. Perfectly full bar informations. Fuck. Damn. Bar impl run. Full bar impl run. What? Pull. So input, okay. And then one more input, okay, and then model arrays as model analysis. Oh, okay, so the module tree generated by this directory structure is as follows: foobar input one. So foobar input or input one. Interesting. Rust lets you split a package into multiple crates and a crate into modules so you can refer to items defined in one module. Rust lets you split a package. Rust lets you split a package. Lets you split a package into multiple crates and a crate into modules and a crate into modules so you can refer to items defined in one module from another module. You can do this by specifying absolute or related passes. These passes can be brought into scope with a user statement, so you can use your shorter pass for multiple users of the item in that scope. Module code is private by default, but you can make definitions public by adding the pub keyword. In the next chapter, we will look at the collection data structures in the standard library that you can use in your neatly organized code. In the next chapter, we will look at some collection data structures in the standard library that you can use in your neatly organized code. In the next chapter, we will look at some collection data structures. In the next chapter, we will look at some. In the next chapter, we will look at some collection data structures in the standard library that you can use in your neatly organized code. That makes sense.